Congruent shapes are shapes which are the same shape and the same size. So they're identical. So if I were to take two congruent shapes and I were to put them over each other, they would therefore fit perfectly. Now, if I were talking about two congruent triangles would mean that the corresponding angles as well as the corresponding sides in the two triangles are the same. So that would mean all the angles in the one triangle equal all the angles in the other triangle, and the same with the sides. Now, to prove congruency, we need three statements and three reasons, all right, to prove that they are congruent. Because if we have the three statements and the three reasons based on our conditions of congruency, which I'm going to get to in a minute, then I will be able to know that these two shapes are congruent, they're the same. Because if I have those 3 points that are the same, it means that the rest of the triangle is the same too. So the four conditions of congruency are side, 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 angle, side, angle, angle, and right angle, hypotenuse, side. So those are our four conditions of congruency. All right, and if we can work with those four conditions, then we can prove congruency. Once we have congruency, then we're able to prove that everything, or to state that everything in the triangle is the same. Now remember, when you're working with congruency, you still have to remember your 9 geometry rules that you've learned thus far. All right, so your 3 rules about straight lines, your 3 rules about parallel lines, and your 3 rules about triangles that you've learned. All right, if we get into the first question, if AE and BD are straight lines with BC equal to CD, prove that triangle ABC is congruent to triangle EDC. And also prove that AB is parallel to DE. Our congruency sign looks similar to an equal sign, except instead of 2 little lines, it has 3 little lines. So that's our congruency sign, and that's the sign that we're going to be using in this video. The other thing that I want to bring your attention to is whenever you're working with a geometry type question, whether it's Euclidean geometry, analytical geometry, maybe your trigonometry questions, it doesn't matter. Whenever you're working with a diagram, you should always ensure that everything written in words is represented on the diagram. What do I mean? Well, have they told you additional information about angles being equal? Have they told you that sides are parallel? Have they told you that sides are equal, etc.? And sometimes the wording isn't always represented on the diagram, and sometimes you need to know that. The other thing that I suggest is that you annotate your diagram. So once you've ensured that all the words are written on the diagram, then what you can do is you can just mark off any additional information that you can maybe see based on your other geometry rules that you know. If we look at this, it says if AE and BD are straight lines with BC equal to CD. So when I see BC equal to CD, I'm just going to check that they've marked it off on the diagram, and they have with those little lines. So we have two sides that are equal. It says then, prove that triangle ABC is congruent to triangle EDC. With our congruent triangles, we also need to identify the order of our triangles, because that's important. So the corresponding information in the two triangles has to match up with the way that you label your triangle. We will get into that a little bit more as well as we go. I'm proving that ABC, triangle ABC is congruent to triangle EDC, and I'm also needing to prove that line AB is parallel to line DE. All right, so if we are going to start our congruency by listing our triangles. So we're working in triangle ABC and triangle EDC. So you can always check that the order is correct in your final step, because in the first step you can kind of just go based on the question. So I need 3 statements, 3 reasons. I have 2 currently, all right? I have 2 lines in the 2 corresponding triangles that are equal, and I need a 3rd one. Now, you can't make it up, and you can't just assume something. So you can't look at the diagram and say, line AB kind of looks like line DE. No, you can't do that, all right? So I cannot with certainty state that line AB is equal to line DE, because there's nothing telling me that they're equal, and there's no representation that they are equal, which means that I can't just assume that they are equal. So that means I need something else. Now, if I look at the diagram, can you see that angle C1 and angle C2 are both marked off, and those are vertically opposite angles. So remember I said we can use our 9 geometry reasons. So vertically opposite angles is one of those 9. So that means that I have 2 sides and an angle that are equal. I can see that angle C1 is included between those 2 equal sides. The other thing with congruency is that we have to keep what's in the first triangle in the first column and what's in the second triangle in the second column. So you kind of have to just keep your triangles in that order. So triangle ABC and triangle EDC. I know that line AC is equal to, which line is AC equal to? AC is equal to line CE. Why is AC equal to CE? It was given to us. How was it given to us? It was given to us with those little markers on the triangle. The next thing that I know is angle C1 is equal to angle C2. Why is C1 equal to C2? Because they are vertically opposite angles. Then I also have line BC equal to line CD. Why? Because it was given to us. So now I have 3 statements and I have 3 reasons, which means that these 2 triangles are congruent. I can now conclude, therefore, that triangle ABC is congruent to triangle, and now I need to pick the order of the triangle, okay, just to ensure. Maybe it is EDC, maybe it's not. You just need to check for yourself. I started at A. I went down the line with no marker towards B. Got to B. Then I went from B to C, and C I had to cross over the line with 2 markers on it, or in my diagram case, it's the green one. All right? So you can see that going A, B, C would be different to going, let's say, for example, in the second triangle, if I started at C. Because if I started at C, now I have a C in both the triangles, so that means I would have had to start at C on the first triangle. So that means I can't start at C. If I started at D, right? So let's say, for example, I went D down to E. Okay, so far so good, because A to B was down the line with no marker on it. D to E is down the line with no marker on it. But if I were to go up to C, now you can see that I'm going up the line with 1 marker on it, so that's the wrong order. So that means that I have to go E, start at E, up the line with no marker on it to D, and then go to C, which is over the line with 2 markers on it, or in my diagram, the green marker. So this will be triangle EDC. So now I've had 3 statements and I've had 3 reasons, which now concludes that these 2 triangles are congruent. They are identical, same shape, same size. Now, I need to, however, finish by stating which condition of congruency I used. Did I use 3 equal sides, side, side, side? Did I use 2 sides and an included angle, side, angle, side? Did I use 2 angles and a side, angle, 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 side, angle? Or did I use a right angle, a hypotenuse, and a side, RHS? So that's what we have to conclude, all right? Now, the only one that is important for the order, really, is side, angle, side, which is actually what I've used here. I've used 2 sides and the included angle. So that means that I can therefore conclude that this is because of side, angle, side. And I just want to show you where each of these came from. AC equal to CE, that was a side. So there's my side. Angle C1 equal to angle C2 is an angle. So there's my A. And BC equal to CD was a side. So there's my side. Side, angle, side. All right, the next question says, prove that AB is parallel to DE. AB is parallel to DE. So we want to prove 2 parallel sides. So I'm going to highlight these 2 parallel sides in yellow. So these are the 2 parallel sides that I want to identify. Now you need to remember, parallel does not mean equal. Parallel lines are lines which remain equidistant apart, all right? So that means the two lines will never touch. It does not mean that the two sides are equal. So by saying AB equals DE, that's not saying that they're parallel at all. So how would I be able to prove that these two sides are parallel? Well, I've just proven that these two triangles are congruent. So what does that mean? That means that these two triangles are identical. So based on the congruency, so I'm going to say, based on this congruency over here that I've just said, that means actually that line AB is in fact equal to line DE. Why? Well, because they're congruent, it means that everything is identical. Okay, I already know that angle C1 is equal to angle C2. So that means that based on the congruency, I know that angle A is equal to angle D. And I also know that angle B is equal to angle D. Again, why do I know that? Because these two triangles are congruent. Now, if I just did a little side note for you, all right? We know that triangle ABC is congruent to triangle EDC. Now, because these two triangles are congruent, because these two triangles are the same, and because I worked with the order of my triangle and I got the orders to match up, that means that I could conclude from the order of the triangle that angle A will equal angle E, angle B would equal angle D in the two respective triangles, and angle C of triangle ABC would equal angle C of triangle EDC. So therefore, I could conclude, you can see in my diagram over here, I said that angle A is equal to angle E. If I look at my representation here, I have angle A equal to angle E. So I could say angle A is equal to angle E. Now, why is angle A equal to angle E? Well, simple. It's because triangle ABC is congruent to triangle EDC. Now, just remember, if you had parallel lines, you would therefore have equal angles, right? So you have your parallel lines, you would be able to have your fun angles. So your corresponding angles, your co-interior angles, or your alternate angles, all right? However, if you don't have the parallel sides given, but you can make the angles equal, then that means that the lines are parallel. So I'll say that again. If I have parallel lines, then the angles are equal. So that means if I have the angles being equal, it means that the lines are parallel. All right, and that's what we call the converse. So I would therefore be able to conclude that AB is parallel to DE. Why? Because it makes the shape of the alternate angles. Alternate angles are equal. Next question, we have triangle PQM and triangle PRM. It is given that M1 is equal to M2 and PQ is equal to PR. So if we look here, it says that M1 is equal to M2. So that means that M1 is equal to M2. So I would be able to mark that off. It also tells me that PQ is equal to PR. So that's PQ equal to PR. Prove that triangle PQM is congruent to triangle PRM. All right, so if I just quickly check the order of my triangles, I have triangle PQM and triangle PRM. Starting at P, going down the marker that is purple to Q, and across to M. Let's see the other triangle, PRM. Starting at P, going down the marker with the purple line, so that's the equal side, and across to M. So therefore, these two triangles are already in the correct order, so I don't have to change that order. So now, I want to prove that these two triangles are congruent. In order to prove that they're congruent, I need to satisfy one of the 4 conditions of congruency. Side, 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 side angle, side angle, angle, right angle, hypotenuse, side. If I look at these two triangles, I already have PQ equal to PR because that was given to me. Then the other thing that I have is I have this line PM. Now, if you think about PM, if you were to, in your mind, ignore this triangle here. All right, so ignore triangle PMR. Okay, then you have triangle PMQ. In triangle PMQ, PM is a side of that triangle. If you, however, ignored this triangle on the left-hand side, triangle PQM, then you would see in triangle PMR, PM is a side. So now, if PM is the side of the one triangle and PM is the side of another triangle, and together they are sharing that line, it means that that side is equal to that side, because even though it's one line, it is common to both of the triangles. If I look at the information so far I have 2 sides that are equal in these 2 corresponding triangles. So that means I could either work with side, side, side by looking for a third side. If I look at the third side is QM and MR, and there's nothing telling me that QM and MR will be equal. So that means I can't use side, side, side. The next one I have is side, angle, side. Now, side, angle, side, you can see that the angle that we're going to be working with will be this angle over here at M, because that's what they've given us. Now, if I'm looking at M, I can see that that's not going to be side, angle, side. Why is it not going to be side, angle, side? Because for side, angle, side, the angle has to be between the 2 sides. So it has to be the included angle. So that means that I can't work with side, angle, side. Then I have side, angle, angle. I don't have anything about other angles. So for side, angle, angle, I need 2 angles, and I only have 1 angle here that I have information about. Okay, so that leaves me with right angle, hypotenuse, side. Now, if I'm looking at right angle, hypotenuse, side, it means that I would be working with angle M1 and angle M2. Now, what have they told us about those 2 angles? They've said that M1 equals M2. But M1 and M2 are next to each other, adjacent, they're touching each other, and they're angles on a straight line, which tells me that I'm working with supplementary angles. What does that mean? Angles that are equal to 180 degrees. So if M1 plus M2 have to total 180 degrees, but they're equal to each other, then that means that each of them is 90 degrees. So that means that I have my right angle over here, my 90 degree angle. Then I have my hypotenuse over here, because that PQ is the hypotenuse. And then this common side over here will be my side. So that means I have right angle, hypotenuse, side. However, I wasn't told that they were equal to 90 degrees. So that's just a little extra step that I need to do just to say, wait, I know that they're 90 degrees because they're adjacent angles on a straight line, and then you go into your congruency. You need to prove all the additional information that you need before you start with your congruency. So I'm going to state that angle M1 equals angle M2. So I haven't started with my congruency yet. Why do I state that? Well, because it's given to me. But I know that M1 plus M2 is equal to 180 degrees. Why? Because of angles on a straight line. So therefore, angle M1 is equal to angle M2, which is equal to 90 degrees. All right, so now I've done a little calculation to say that they're each equal to 90 degrees. So now I can start my congruency in triangle PQM and triangle PRM. What do I know? I know that side PQ is equal to side PR. Why is PQ equal to PR? It was given. I also know that PM, side PM, is equal to side PM. Why? because they are common to both triangles. So it's a side that's common to both triangles. And then my last one is that angle M1 is equal to angle M2. And I can either say given because it was given, or I can say proven. So I'm going to say given or proven. So therefore, I have three statements, I have three reasons, so I can therefore conclude that triangle PQM is congruent to triangle PRM. Now remember, you state your congruency, but then you have to write out your condition of congruency. So this condition of congruency is right angle hypotenuse side, and I'll just color code it for you. The right angle is over here, which is the M1 and M2. The hypotenuse was the side that they were given. And then the additional side is just the side that we proved was common. So there I have right angle hypotenuse side. The next question says that we must prove that QM equals MR, that QM equals MR. So if we look at QM and we look at MR, those are the remaining sides of the two triangles. Now remember, we've just proven that the two triangles are congruent. So if we've proven that the two triangles are congruent, it means that everything about the two triangles is the same, which means that the remaining side is also equal. So we could just state, therefore, that QM, line QM, is equal to line MR. And why is QM equal to MR? Well, simple, because triangle PQM is congruent to triangle PRM. Last question. We have lines JN and KM being straight lines. Prove that triangle JLK is congruent to triangle NLM, given that JK equals MN and angle J is equal to angle N. So we're going to just start and check that everything is listed on our diagram. So we have JK equal to MN, JK equal to MN, that is represented, so that's good. We also have that angle J is equal to angle N. Angle J, it's represented with this little dot, is equal to angle N, which is also represented by the little dot. And I want to prove that the two triangles are congruent. So if I just look at the order of my triangle, the first triangle I have here is triangle JLK. So starting at J, so starting at the purple dot, based on my diagram, going down to L, and then across the line with no marker to K. So if I were to just check if the order is correct in the second triangle, NLM, starting at the dot, based on my diagram, it's a purple dot, going down to L and up the line with no marker to M. So therefore these two triangles are in the correct order. All right, I can just start with my congruency then. Three statements, three reasons, triangle JLK and triangle NLM. All right, if I look at these two triangles, do I have three pieces of information? So far I have a side and I have an angle. So a side and an angle eliminates side, side, side as one of my reasons. I have four conditions of congruency, side, 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 and the last one, which is right angle hypotenuse side, and there's no right angle here, so I'm not going to use that one either. So the only two remaining conditions of congruency that I have would be side, angle, side, and side, angle, angle. So two sides and an angle, or two angles and a side. So based here, I have one side, one angle, so it could actually be either of those two at the moment. So I'm just going to look for my extra piece of information. So I need a third piece of information. There's nothing telling me that the additional lines are equal. What I do, however, have is that L1 and L2 are vertically opposite angles. So that means that I now have a side and two angles. So I'm going to start by stating my side. So side JK is equal to side MN. Why? Because it's given. Then I have angle J equal to angle N. Why are they equal? It was given. And then the last one that I just have now is L1 is equal to L2. Just remember, what's in the one triangle must stay under the one triangle. What's in the other triangle must stay in the other triangle. So that means that L1 will come first because that's the first triangle I'm talking about. So angle L1 is equal to angle L2. It wasn't given. I'm using my geometry rule of vertically opposite angles. So therefore, I can then conclude that triangle JLK is congruent to triangle NLM. I need a condition of congruency, and that will be side, angle, angle. Quickly, if I'm just looking at where it comes from, the side would be JK equal to MN. The angle would be angle J equals angle N, and then the other angle would be the additional angle of vertically opposite angles that I used. Don't forget, the more you do, the better you'll be. Keep practicing.